Okay, so this is a final exam review, and what I'm going to do is work through each question one by one to make sure that you understand the procedure and what they're testing and the actual question. So as you listen to this video, just watch for procedures, listen to little key phrases I use, and it should help you understand what we're testing you in. So we're going to begin with factoring. And in this case, basically the directions are to factor completely. So what you want to do is you want to, we're going to look at the first term, and we're going to ask what can give us 3x squared. So we know that definitely a 3 times 1 is going to work. And so this has to be the 3x, and the other side has to be the x. So 3x times x gives you 3x squared. Now the question is, how can we obtain a product of negative 14, which means that one has to be a negative, one has to be a positive. So I'm going to go with the plus here and the negative here to start, and let's see if we get lucky. And now I'm thinking that if I put a 2 here and a 7 here, that this would work. If you notice, this looks like answer choice A. The question is it the correct answer? So I know that 3x times x is 3x squared, so we're good there. I know that positive 2 times negative 7, that's definitely going to give me a negative 14, so I'm good there. What I have to check now is the middle. Is this going to give me 19x? And the question is, I need a negative 19x, so this is going to give me negative 21x, and this is going to give me positive 2. So as we know, negative 21 plus 2 would give us the negative 19x. So actually, I guessed correctly the first time. If you don't, then you just continue, and you continue to try. Now, for some of you, it might be easier to go the other way, using the answer to actually answer the question, but it'll take you more attempts. So if you multiply, for example, if I was to choose answer choice B, 3x times x, yes, that gives me 3x squared. Negative 7 times positive 2, yes, that gives me negative 14. However, this gives me a positive 6, this gives me a negative 7, so that means that middle term would have been a negative 1, so that's not the answer choice. So you can use that strategy for these other two, and obviously it's not none of these. So. Alright, so for question number 2, again, factor completely. So you're trying to get terms that are like. And so what I would recommend in this case is separate any term. If you notice that the term r, or the value r, is consistent in all 4 of these terms, so the first thing I would factor out would be the r. So right now I have r parentheses 2s plus 3st minus 8, and I have a minus 12t. Notice that all the r's are now out. And so now I have to factor out these terms. If you look carefully, you'll notice that both of these terms have the st, and this term has no variable. This term only has a t. So I'm thinking that if you do factor by grouping, that would work. Or you could also take these 2 terms, group those 2 together, and then leave these 2 and group those 2. So if we do that, based on what they have in their shared component, I'm going to take the 2s minus 8, and I'm going to factor that, and I'm going to leave the 3st minus 12t, and I'm going to factor that. So if I take out the 2 in this case, I'll have s minus 4. Mind you, there's an r sitting out here. And over here, if I take out the t, actually I'll take out a 3t, I'm left with s minus 4 again. So s minus 4 is my shared term. And then this part becomes r parentheses s minus 4. And what's left over here is simply the 2 plus 3t, because remember the 3t is a positive, so there's a plus in between there. Okay, so that's not that tough a question. You just have to sort of figure out what they have in common and use that. For the next term, same process. In this case, this is a trinomial. So if I were to take out what's common, I would have to think of this as, if I take out the 2, then this is going to give me 2 parentheses x cubed, and this becomes plus, remember I'm dividing this by 2, so this will become 27. Alright, and so this is where the trinomial comes in. So if you remember the trinomial, it's the first expression is x plus 3, because this is 3 cubed, right? You gotta remember that. So this is x plus 3, and this becomes x squared. This becomes a minus 3x and then a plus 9. So your final answer will actually be 2 parentheses x plus 3, x squared, minus 3x plus 9. So this is answer choice D for your question. Just remember, in trinomials, once you factor out the 2, since you end up with x cubed plus 27, 27 is 3 cubed. So you really have an x cubed plus 3 cubed, right? And that's how we know to use that pattern. And that's something we cover in the course. For number 4, it says determine the values of x for which this rational expression of x squared, or x minus 4 over x squared minus 9 is undefined. In that case, you're always focusing on the denominator, and your answer choices should be plus or minus 3, because that'll make the denominator 0. So the question you're asking yourself in this case, if this is x squared minus 9, then x can never assume the values are plus or minus 3 because it's squared, which will give you 9 minus 9, which is 0, and we can never have 0 in the denominator. So that's answer choice B. Okay, for number 5, what I would do is always use keep, change, flip to start. So I would change this to multiplication, and I would flip this so you have 2x plus 6 over 4 minus x. Alright, and then I would factor out values that are common. So for example, this would become 2 parentheses x plus 3, and this is actually the negative of x minus 4. And so those are your new values for those two expressions. And if I factor out the 4 here, this will give me x minus 4. So you can already see that the x minus 4s are going to cancel. If I factor out the 5, this will give me x plus 3. And again, you can see that the x plus 3 is going to cancel. So in this case, here's what's going to happen. This is going to cancel with this once you extract the negative. This is going to cancel with this. So for number 5, you'll notice that you'll end up with negative 8 over 5. You have 4 times 2 at the top. That's the 8. This is 5 times 1, so 5, and obviously the negative stays. So there's negative 8/5, and that should be your answer choice for that, which is answer choice C. Alright, and then for number 6, it says add, then simplify. So for this one, you have to consider what is common to the denominator. This is x minus 3, x plus 3. This, if I factor this out, this will become x minus 4, x plus 3 for the denominator. And what you have to ask yourself is what is common to both sides of the equation. So if I look at this side of the fraction, this is missing the x minus 4, so this will become 2 parentheses x minus 4 plus, and this side over here was missing the x minus 3, so this becomes 5 parentheses x minus 3. And so when all is said and done, you end up with 7x minus 23 for the top, which this is the only answer choice that has that. Notice that this x plus 3 is not repeated, so we don't repeat it just because it's there. Okay, so we don't repeat this x plus 3. We only use it once. Okay, excuse me, for number 7. For number 7, So simplify the complex fraction. Alright, so if we simplify the complex fraction, remember this is 3 over 1. So I have to multiply both sides by x on the first part of the top of the fraction. And this gives me 3x plus 7 over x. All of this is over this fraction. Notice this is also missing an x, so this is xy, that's just x. So I have to multiply the top and the bottom by x. So this becomes 1 plus 2x. That's the top part. 1 plus 2x over xy. 1 plus 2x over xy. And then we keep change flip. So understand that when we keep change flip, what's going to happen is I'm simply going to change to multiplication up here. This is going to flip, so this will become up here xy over 1 plus 2x. So if you notice, the x's will cancel here. Right? So the x's will cancel. So this cancels with this. And this leaves me with 3xy plus 7y over 1 plus 2x. Okay, and that's your answer, which should be answer choice B. Okay, so for the next part of the equation, same difference, we still need a common denominator. We're trying to solve for x, where this will equate to this. And so to do that, you need a common denominator. So the first thing you're going to do is literally take the 3, we're going to multiply by 3 over 3 on this side of the equation. And on this side of the equation, we're going to multiply by 4 over 4. So we're going to end up with 12x plus 3. All of this minus 8x, and this is in parentheses, so 8x plus 12. And all of this is over 12. And this is supposed to equal 7 over 12. So we're okay as far as the denominator part. What we need to solve for is the top. And so to do so, we distribute the negative. So this will become 12x plus 3 minus 8x minus 12. And if I combine like terms, I get 4x minus 9 equals 7. So I'm going to end up adding the 9 to both sides of the equation, leaving me 4x equals 16, and therefore x is equal to 4. And so your answer choice is A. You can always check it just to verify. Question number 9, it says what is equivalent to this? Well, first of all, this is a cube of 27. So that's a cube of 27. Okay, this is raised to the negative 2. So that means that this is squared, and it's underneath the fraction bar. And so if you look at your answer choices, this is answer choice B. Remember, we don't like negative exponents. Okay, number 10. Number 10, we're adding the square root of 8 plus the square root of 18. Now, what we need to do here is we need to find a value that is shared among the two. If I look at this carefully, I have the square root of 2, so I could do square root of 4 times square root of 2, that'll give me square root of 8. Plus, since I'm using square root of 2, this would also give me a product of square root of 9 times square root of 2, which is square root of 18. These are both perfect squares. So that means that you have 2 square root of 2 plus 3 square root of 2, which is going to end up giving you 5 square root of 2. Answer choice C. That's the first 10 question. I'm going to stop here. The next 10 are coming up.